So hi everyone, welcome to another episode of the CodersArts. So in this video, we are going to showcase one more project that is domain of machine learning. So one of our team member will explain throughout this project. Maybe in project basically we'll target like what are the code walkthrough, what are the problem statement. Moreover, we will try to see how we implemented this project. So basically we are going to showcase more of the core functionality, and based on that you will get more idea. Based on that we also can create more creative or more responsive user interfaces, but that is will come later. But in this video basically we'll target all the core functionality. So one of our team member Pratibha will explain what she has built for in this project. So okay, so I'm inviting Pratibha. So hi Pratibha, now we can start about your.
Hello everyone. Today we are going to talk about scene recognition. Is my screen visible?
Yes.
Okay. So in scene recognition, what we are trying to do is we are trying to classify videos instead of images. So it is something similar to image classification, but
Mhm.
there is a catch here. So let's just first familiarize ourselves with the data. So
Mhm.
for in this case, we have two types of videos with us, in which one the camera is stationary, and
Mhm.
in the other one the camera is moving on its own axis. Let's just check it out. So you can see that we have a lot of categories with us. So it is a multi-class classification problem. For example, there are video clips for beaches, streets, and railway station. So let's just check out one of them. So these are the clips from the static cameras. So in this, the camera is not moving, although the elements of the video may be moving in there.
Mhm.
Let's just see one more example. And in the moving camera videos, it is something like this. You'll see that the camera is also not stationary.
Okay.
Okay. Let's just see one more example. So this is the objective of this project, that we want to classify these videos into their corresponding classes.
Okay. So
So
we,
now, yeah,
okay. So video will
yeah.
be static and uh, so yeah. Or
Yeah,
is we.
we'll be using both kind of videos,
Mhm.
camera like stationary camera and the moving camera together.
Mhm. Okay. Fine.
Yeah. So the model would be able to classify both kind of videos.
Mhm. Okay. Okay. So first, Pratibha, explain like if this type of project is somebody want to build. So in which category this project belongs to? Like where like in the machine learning, deep learning, or any algorithm. So
Okay.
how?
Yeah.
Yeah. Okay. Go ahead.
Yeah. You can complete your question.
Okay. So I was asking like
Yeah. Hmm.
this type of projects like obviously these are video type like it might be the project that is uh, data type is video, right? So other than that, like what are the technology behind it, like which algorithm we should use? So is there any decisions like if this type of project is there, if type of data is there, so this type of algorithm, or if not algorithm, so where this belongs to, like this belongs to deep learning, computer vision, NLP. So I'm asking in this context, so where this type of projects belong to.
Okay. So basically, it belongs to deep learning category. Okay.
Hmm. Hmm.
And later on, when the model has been trained, it can be
Hmm.
shifted to computer vision as well,
Hmm.
for the purpose of implementation. Like right now, what we are trying to do is we are just trying to build a model that is able to classify. Okay. But
Hmm.
in order to make its use case,
Hmm.
eventually we'll be using computer vision. Like we'll be integrating this model with the computer vision code,
Hmm.
so that an AI robot or any machine will be
Hmm.
able to just look at the video, assess it, and then classify it. So it majorly falls under deep learning, and
Hmm.
even computer vision is also making use of deep learning itself. But if we are to classify, then I would say that first it is deep learning, and for its implementations, like for it generating its use cases, then we'll be shifting to computer vision.
Okay, okay, go ahead. So,
Yeah.
go ahead.
And yeah, you added one more question, like what kind of algorithms we should be using in here.
Mm,
So since it is dealing with images, and like everybody knows that deep learning is the choice when it comes to classification of images. So here
mm,
also we are using deep learning, but the models that we can use are convolutional layers like CNNs, and
mm,
we can also use some pre-trained model. In this example, we are building upon pre-trained model ResNet, but
mm,
we can also use VGG as well, and other
mm.
pre-trained models which are specifically being used for image classification.
Okay, okay. Start with like
Yeah.
uh, uh, projects flow, like starting with the code, like importing the library. Okay, so go ahead and make code work through.
Yeah. Okay. So first of all, in this case, because our data is present in various folders, so it
Mm,
is very important to set the working directory so that
mm,
we are able to access the data.
mm,
So first of all, since we are using Google Colab, so we
mm.
have mounted the Google Drive, and then after we set the working directory. After
Okay.
that, in the working directory, we have defined the paths for the stationary data and the moving data, like the stationary
Mm,
videos and the moving camera videos.
mm,
And we have just checked here that we were able to, you know, give the correct path here. After
okay.
that, we were just trying to load the data here.
Mm,
Now we cannot directly like pass in the videos to the model itself, to the
okay.
deep learning models. Okay,
Mm,
so in that case, what we can do is we get frames from the video. A video is nothing but a collection of frames, right? Which is like over time, if you are going to run it, you will see that it is moving, like there is some kind of animation between them. So
mm,
you can refer to a video like an animated set of images. Okay, so
mm,
you must have seen those kind of books, flip books, right? Where there is a drawing in each page, and when you flip the book, then you see that there is an image, like animation in the drawing, right? So
mm,
it is something like that concept is being utilized here. So we are just reversing it, like instead of making it movable like animated, we are trying to make it stationary. So uh, to a particular video, we are extracting frames from it. So what we are doing is eventually, though our task in here is to uh, classify videos, but actually in the essence we'll be
mm,
classifying images only. So first of all, what we have done in the code is we are trying to transform the data to according to our needs. So you can see here that from the stationary camera videos, we are extracting the images and saving it. So we just run this code once, and let me see. These are the frames. I'm just giving an example that these are the frames from the videos. Okay, this is from the moving camera,
mm.
and
Yes.
similarly, we have done with the stationary ones as well. Okay,
Okay.
so
So,
you can see that.
so after running those
Yeah.
code cells, so this frame are generating by code,
Yeah,
right?
yeah. Once
Um,
we run those code for both stationary and moving cameras, we
mm,
will get these set of images. Like if you are going to collect these set of images and
mm, mm.
speedily just move around them, then you will see that actually these are the video clips itself.
Okay.
So
Okay.
we are just extracting the frames here.
Mm,
You can see that similar videos are there one after the other, but
mm,
actually they are varying very slightly.
mm,
Yeah. So this is what we do. Like we get the data, we are converting the videos into a set of images. Like we are extracting the frames from the videos.
mm. Okay.
Okay.
Okay. Perfect.
Then what we are doing is we are just like labeling the data as well. Like obviously we need, like even if we have the images, we need to pass the class. Like we are creating the target as well.
Mm,
So as you could see here in these folders, the target or the class name was present in the name of the folder, right? So
mm,
here we are converting it into a data frame where the like name of the file is there, the name of
mm,
the frames that we have stored using the code above here. Okay,
mm,
and then their corresponding class has been stored. So this would be a very useful format for us so that we can just directly get the path of the file and its class.
mm.
Okay,
Okay.
so once we loaded the data file and we
Mm,
have the relevant paths and their corresponding targets,
mm,
we do some EDA, like we check out the class distribution, because
mm,
in order to avoid any kind of biases in our
mm,
model,
mm,
we need to make sure that all the categories are having the same number of examples.
mm,
Okay,
mm,
so here we see that is not the case. So there is a class imbalance in here, and we need to either downsample all the data to the lowest one. Like here we can see that highway is having the lowest count of frames.
mm,
Okay, the video may be shorter.
mm.
So because of that, and then again there are a few videos which are having a higher number of uh, frames as well.
Frame.
So in this
Mm,
case, what we are doing is we have used downsampling. Okay.
mm,
So here we have made all the classes to be having equal number of examples as the highway class. But
mm,
usually this is not a very good approach. We should be doing data augmentation in here so that
mm.
we can, uh, create new images based on the images that we are already provided by just slightly changing them, like by maybe rotating them or flipping them. Okay,
Okay.
so
Okay. Just a
using
second.
that way, yeah,
So
yeah.
what is data augmentations?
So data augmentation is actually augmenting the data, like providing more examples of the same kind, because we don't have. So what like if in this example we say that there are a few categories in which there is less amount of examples, right?
Mm,
So
mm,
we want to increase their level to the highest example. Like for example, falling trees, we can see here that it is having the highest number of examples, and there are
mm,
some other as well, like
mm,
ocean and railway. So
mm,
we need to increase the count of these classes where the count of examples is lower to the highest class. Okay, so we need to generate data. So that is what data augmentation is. Like we have some frames from highway. Okay,
mm,
so what
mm,
we can do is to those frames we can add some slight variations, like we can maybe rotate them by some by a few degrees only. Okay,
mm,
or maybe we can just flip the image, right? So maybe we can add some shearing. So all
mm.
these things, like the image would remain the same, but it will be slightly different from its original counterpart. So in that way we create more data to
Mm.
suffice in here in order to make the count equal. So
Okay.
that is data augmentation. So there are two approaches. Maybe we can upsample or we can downsample. Okay.
Mm,
In
mm,
this particular case, according to the need, we just used downsampling. And
mm,
downsampling is also not a bad approach if we have a lot of data. Okay.
mm,
For example, here we could see that almost 300 frames per video is there for the
mm,
higher counts. Okay,
mm,
so though it is less, but let's say if it was very high, let's say we have thousands of images, and in that case some of them were a few thousands. Okay, so in that case we could have downsampled as well. Like if the difference between the high count and the lowest count is not that much, then we
mm,
may use downsampling. But in downsampling what we are doing is we are losing important data. Okay, like for these classes like falling trees and rushing river, railway, we had enough data but we are not utilizing it, so it is actually a waste. So that is
mm,
why downsampling is not preferred. But if let's say highway also had, let's say around 275 examples of frames. Okay, so in
mm.
that case we could have used downsampling, it would not have mattered that much. So these are the two
Okay.
approaches
Mm,
to remove the imbalance in the class. Okay,
okay.
yeah. So After downsampling, you can see that all the classes are having the same count. So now the frames for each class are equal, and equal amount of frames would be introduced to the model. So there we are reducing the bias by doing that.
Okay.
Yeah. After that, we are extracting features from the images. Okay. So
So what is
feature
LBP?
extraction.
So
Yeah,
what is LBP?
yeah, I'm coming to that.
Okay.
Here we are using LBP feature extraction. So LBP
Mm.
means localized binary pattern. Okay.
Okay.
So
Mm.
let's say we are taking this frame. Okay.
Mm. Mm.
What LBP is doing is it is going to, take one reference point in this image, and based
Mm.
on its intensity, it is going to convert this image into a binary image. Okay.
Mm.
So based on the intensity of the reference that has been chosen in the image, the intensity of
Mm.
all the other parts of the images will be, calculated. And the feature would be something like this. It may not be visible in here. Let me just increase the brightness. Are you able to see that there is some grayish part and then there is some black part here? Like, is it
Yeah,
visible?
mostly I'm able to see black part only.
Oh,
Okay.
yeah,
So
that may be an issue, but in my screen, I'm able to see it. It's just that the
mm.
intensity in that image is not that
Okay.
great. So it is like this.
Mm.
But if you are running the code yourself and you try
Mm.
to see, like just increase the brightness and just zoom in, you'll see that there are a few lines, okay, in
Okay.
grayish color.
Mm.
So these are the localized binary patterns. And
Mm.
now there are only two colors, like gray and black in here. Okay, in the image
Mm.
itself. So now what we have done in this is the color aspect of it is gone. Okay, so now
Mm.
to this model, like the model that we are going to build, we will pass these kind of extracted features from the image, and it will
Mm.
and it is these images from which the model would learn its features. Okay, so
Mm.
we are actually making it easier for the model to understand. For example, we'll discuss it later when we are discussing the working of the model, that how it's going to work. So what our
Mm.
model does is, let's just come to it. One more thing before coming to the model is, like, we are one hot encoding a target variable as well. Okay, because
Mm.
as we all know that machines are not able to understand normal English. Okay, like here the class has been defined as beach and highways and falling trees. So obviously the model is not going to understand it. So we have encoded it into a form which is easily understandable by the model. Okay, so for this purpose we have used one hot encoding, as it is the best method to encode
Mm.
these kind of categories.
Mm.
After that, we are just splitting the data into train and test. That is a very general approach, like everybody knows it. Okay,
Mm.
so it's just that we'll be training the model on the train set, and after the model has been trained, we'll be testing its performance using the test set. So that is why we keep aside some test set from the data in order to
Mm.
perform, in order to evaluate the performance of the model later on.
Mm.
So we don't pass the like the test set anywhere to the model during the training phase. So like it is completely unseen to the model.
Mm.
So once we are done with that, we come to the model. So like we could have made our own CNN architecture as well, but that
Mm.
takes time and a lot of hypertuning as well to generate great accuracy. And
Mm.
because in this particular project we had to use some pre-trained model, like we were told that we are free to use any model, so we chose ResNet
Mm.
50. And
Mm.
ResNet 50 is a pre-trained model which contains 50 layers, as the name suggests, and it is containing 50 residual blocks. So in each residual blocks, there are at least 1 to 2 CNN layers. Okay,
Mm.
and this particular model has been trained on ImageNet, which is a very huge set of data, like like these are only just few examples of targets in here in this particular project, but ImageNet is a very big set of differently labeled images on which this
Mm.
model has been trained. And or like we cannot locally train this kind of model. Okay, it is like
Mm.
computationally very expensive.
Mm.
So what we are doing here is we'll be using transfer learning in here. Okay, so
Mm.
this ResNet 50, I would say that it is like specifically made for the purpose of classification of images. ResNet 50
Okay.
is there, and then if I am to name one more example, then VGG 16 is also there. Okay, so
Mm.
these two models are um, like generally used for image classification purposes. So in this project we are using ResNet 50. And
Mm.
transfer learning, like I have named it here, so I'll explain a little bit of it. Like this model is already trained, so its weights are like it has already learned some features from all the images that it has been trained on, right? So it may be so that some of the images, like obviously because the data set, like ImageNet data is so vast, so there would have been some images of beaches in there already, some railway station or some oceans. Okay, like the classes that we are having in here in the image may be somehow present in that um, ImageNet dataset as well. So this model has already learned a lot of features of an image and learned to classify them. Now what we want to do is we just need to fine tune it to our own data. So this is what transfer learning is like. We'll be starting with the weights which is already stored in the ResNet 50 model in here, and then we'll be training it on our own data so that it will learn its feature more better. Like it has already learned the features as it is a pre-trained model, but in this case also it will like build upon its previous result and make the new results for our own particular data set as well, so that we'll see later on that accuracy would be really nice because the pre-trained model is already very nicely trained and had a really nice accuracy. Okay,
Okay.
so coming to the working of it, we'll see how transfer learning is working in here. So here we are loading the pre-trained model in here, the ResNet 50. Okay, and
Mm.
we are adding it to our base model here, and then we are just compiling it here. Like after here, I forgot to mention, like we have accessed the ResNet 50 here, and to this we have just added one dense layer at the end. Okay,
Mm.
so here we have 20 classes with us. As you can see, these are 20 folders. Okay, so 20 classes. And at the end, we have just added one dense layer, fully connected layer, which will be giving an output of 20. Okay, as we have 20 targets in here, and
Mm.
added the softmax activation function as well in there,
Mm.
which is used for classification purposes. Okay, one of the
Mm.
activation function for classification.
Mm.
So this is the whole architecture of a model. Like ResNet 50 is there, and after that, one dense layer.
Okay.
Once the model architecture has been set, we are just compiling the model. Like we have added the optimizer. Like the choice of optimizer in here is Adam because it performs
Okay.
really well, and the learning
Mm.
rate is also set in here. And then the loss function is also defined. That is categorical cross entropy. Okay,
Mm.
because when we have more than one category, then we make use of this categorical cross entropy. Otherwise, we have just binary cross entropy as well when there is only binary classification in. Also, for
Mm.
metrics, we have chosen accuracy in here. Then we just set the epochs and batch size and train the model, and we can see that the accuracy was 99% and validation accuracy was also 98%. So the model trained really well.
Mm.
Okay, so this is the training of the model ResNet 50. After that, what we are doing is we have just saved that model and we load it for making the predictions. Now, since it is in the format of images, so the like prediction is also going to be the same way. Like we are just going to pass in the frames in here. So here we have defined one function that will to which we'll pass the frames. The frames is also one of the parameters, like one the only parameter. Okay,
mm,
so to this we'll be passing in the frame, and we'll check like with how much probability it is actually classifying into different targets. Like obviously the model is 98% correct and not 100% correct, so it's going to make some mistakes, right? So
mm,
let's just see. For example, in one case here we are giving, like, passing to the function the frame of beaches. Okay, so once we make the prediction with for the beaches, we see that it is like almost 97% of the time it is correctly classifying beach, but there are few cases where it is confused between a beach and a rushing river and an ocean,
mm,
and which is expected because there is water body in all of these, right? So
mm,
this is the evaluation of the model that we are doing in here. The same way we pass in fountains, and in that also it is majorly classifying it as a fountain, like the frames, all
mm,
of the frames. But there are some instances where it is like getting confused between a fountain and a highway or a
mm.
marathon. Okay, so this this was the entire project.
Okay.
Yeah, the next step that could have been done in this is, like, we already have this saved model, right? So I
Mm,
told you
mm,
that we can use it in computer vision as well. So now
mm,
what we are going to do is, like, what we can do is, like, we'll just write another code using computer vision, in which we'll be using making use of this trained model. To this model,
mm,
using a cv, what we are going to do is we'll pass the feed to it, and it will classify like whether it is a beach or a mountain, and we can see that happening into a video itself. Okay, like
mm.
it will just label it. Okay, this video is for beach, this video is for road. So that's
Yeah.
how
So
it generally works.
mhm.
Yeah.
Yeah. So simply we can convert into any app. So we can convert any web
Yeah,
app. So
yeah, so
basically,
this is the back end of it.
mm,
This is
mm,
these kind of things are actually happening in all the machine learning models or apps
mm,
that you are seeing, that
mm.
we code it, we save the model, and that model is then used in the apps at the back end.
Okay, okay, fine. Okay, so now
Yeah.
let's recap into like 1 or 2 minutes. Like so how the scene recognition works. So let's explain in the different step. Like I'm just giving the what are the different stage. Like first loading
Okay.
the explain like first loading the data using this library, then
Mhm.
training this. So I'm explaining what are the flow of the project. Explain like this. How we can
Okay.
build the scene.
So, in this entire project, what we learned is, like, how to tackle the problem first. So,
Mm,
instead of using the videos, we made use of
mm,
images. Okay.
mm,
For this, like, we extracted frames from it. For that, we used OpenCV library. Okay.
mm,
So, to extract the frames from the videos, we use
mm,
CV2 library and the
mm,
math library, and then
mm,
we also made sure that the dimension of the images are same. So we have
mm,
already set the height and width to be 150, so that there is a uniformity in all the frames that we are extracting. And once we were done with extracting the frames, we just made a data frame out of it, like with the path and the target class as well. And we checked the class distribution, and we saw
mm,
that there was an imbalance, and for that we used downsampling in this case, but upsampling is more preferred using data augmentation. Maybe we can discuss it later. And here, then after that, we like, there was one more step before training, that was feature extraction. Feature extraction aids the model in learning the features from the
mm,
images. So for that, we just visualized one image and its feature extracted, but it is not visible. But if you are going to run it on your own end, then you will be able to see that, okay, there are some lines going on in here. After that,
mm.
we one hot encoded our class and splitted our data into train and test sets. And then after that, we just loaded the pre-trained model, added one more dense layer to, like, produce the output from it, and
Mm,
then we trained the model. So the accuracy was also very great. We saved the
mhm,
model, and we again loaded the saved model and
mm,
made some predictions to
mm.
check the performance of the model, and that's it.
Okay. Okay, perfect. So,
Yeah.
okay. So what is the real use of this type of projects? Okay, so how maybe some, okay, just give real use cases of this type of projects to whom this will be very helpful.
Basically, this is just to make the machines to learn to classify scenes, because as
Hmm.
humans we are able to make out, okay, this is beach, and that is a road, and that is a marathon, like people are running in there, but machines don't know it, right? And
Hmm.
since we are going forward with AI and development and all these things in this sector, so this is one of the building blocks, like such as image classification works, okay. So the whole point of all these things is to like automate the tasks, okay.
Hmm.
So let's
Hmm.
say if for image classification I can say that let's say there is a website, okay, a shopping website, let's say. So
Hmm.
it will be able to classify, if we train the model in such a way that it will be able to classify a dress from a jacket from a bottom. So
Hmm.
we can automate all these things and save time. So when we are actually making the listings of all these kind of products, so we can just
Hmm.
write a code, we can use a trained model, and it will just assign the label, okay.
Hmm.
Or else let's say at the billing counter we don't want any person to be there, or we just want to make sure that there is a double check or double security, let's say. So that let's say if a person has made the bill, it will just again, by making use of the camera, it will just assess all the contents of the basket and will
Hmm.
calculate the bill, and we can cross check, okay, it's correct, right? So there is no mistake. So all these things just for the purpose of automation is only all these things are necessary. And for this particular case, like the scene recognition, it can be used in any industry that is related to media, okay. Like
Hmm.
maybe it may be the film industry, or it may be, news sector as well, or let's say in defense also, like where
Hmm.
surveillance is required. In that case also it can recognize the scene, that okay,
Hmm.
something like this was happening, or it is the
Hmm.
scene of a particular, it is a desert where the person is, okay, or the person is in a boat in an ocean. So all
Hmm.
these kind of use cases I could think of right now, okay. But
Hmm.
obviously there the opportunities are endless with all these kind of things, like people can get really creative.
Hmm. Yes, yes. So
Yeah.
the main technology we have already said, right? How the things work
Yes.
based on
Yes. Yes.
their use cases. So it's like basically detecting the scene, or maybe data annotation, data
Yeah, scene
labels.
recognition, detecting the
Hmm.
scene, like what scene is
Hmm.
actually playing in front of the
Hmm.
machine.
Yes, yes. Because human, 24-hour human is not attentive. Sometimes
Yes.
they feel
Yes.
dizziness. So that's why I mean this type of
Yes.
things are required.
Yes, just to aid
Okay. Okay.
humans in their work.
Hmm. Yes, yes. So there is numerous use cases. So based on the
Yes.
need or demand, somebody can use. Okay. Okay. So as a student point of view, so how you
Hmm.
recommending, like, to whom this should learn this type of project? So is it come under like beginner level, or somebody is come under intermediate or specialized, somebody in a specialized in type of video, like there is different type of work on based on video, right? Somebody like in camera facing traffic signaling part, so there
Yeah.
is many things work on this video. Okay, so to whom this type of project is very helpful, or they will, if somebody starts, what they will learn from this project.
Okay, well, from students' point of view, all those who are interested in AI and
Hmm.
machine learning should
Hmm.
learn all these kind of things, because here we are just using a pre-trained model. So the first
Hmm.
step that you could learn is how to work with pre-trained models, and
Hmm.
maybe then when you understand that how these models are working, you can try to create your own architecture as well according to the need.
Hmm.
And or maybe you can reverse the approach as well. You can first try to build some basic architectures, CNN architectures, if you are working with image data, and
Hmm.
then make use of the pre-trained model and compare your performances. It's not like that with ResNet only we were able to achieve an accuracy of 99%.
Hmm.
We can do the same with our own architecture as well. It's just that it is a time taking process, it's like research, okay. So
Hmm.
you will be adding layers, you'll be deleting layers, you will be changing your optimizers, or you will change
Hmm.
running learning rate, and maybe your loss as well. So like all the combination you are going to try when you are learning all these kind of things or building your own model. So if you don't have time, then obviously the best approach is to use pre-trained model because they guarantee a higher accuracy. And
Mm,
so for students, yeah, whoever is interested can learn. Apart from that, like if we are not talking about the students, then obviously developers who are into machine learning, they are, you know, the audience or the target people who should learn all these kind of stuff, because it will help.
mm,
But in again, in machine learning and deep learning also, there are various fields. So
mm,
let's say machine learning is completely different, there more data analytics is also involved in here. Deep learning, these kind of, transformation of the data, some like the way we did here, like we extracted, first we extracted the frames and then we extracted the features. So these kind of thing, you need to know. So until and unless you don't work with these kind of data, different kind of data in deep learning also, you won't be able to like have a plan for approaches, like how you can deal with the data. It's not just the image data. These days we are working with audio data as well. So
mm,
different kind of data requires different kind of transformings. So if you are not working with all these data, then obviously you won't learn this. So for developers also, it is necessary to like practice all these things.
mm,
So yeah, and then also not all the developers, only
mm,
those who are into deep learning, or maybe those who are into computer vision field of it. Because in
mm,
machine learning also, as I stated, that machine learning is there, deep learning is there, and then there is computer vision that is slightly different, but it is built upon deep learning only, right? And
mm,
after that there is NLP that deals with texts, and then audio also is there. So that is entirely a different field, although it is again using deep learning, but the two,
mm,
like images, videos and audios, are completely different.
mm. Yeah.
Yeah.
Yeah, perfect. So yeah, basically, like, whenever you're a machine learning developer, so I think working on different type of data, so obviously there might be some specialized skills. So
Yeah.
I'm recommending, as like we are starting a beginner. So maybe you
Yes,
need
yes.
to know, like, first you all the basic thing, working with basic machine learning projects, it will be loading data in the form of CSV format, right? So
Yeah.
later it might be images, later it will be videos,
Yeah,
then later it
even
will
if
be.
it is not CSV, then in tabular
Hmm,
also, like the data may be in the form of JSON or an
hmm,
XML or an Excel sheet, or
hmm,
maybe a TIFF file. And there are a
hmm,
lot of different types of data types. So
hmm,
so not data types, sorry, data formats. And
hmm,
if you are not familiar with them, like if you have not worked with them, then you won't be able to understand like how to deal with it. So
hmm,
we need to obviously, if there is like if somebody is a machine learning developer or a deep learning developer, then like they can work with different fields. Like a deep learning
hmm,
developer can do machine learning jobs as well, and even NLP. So it's
hmm,
just about the exposure that they are having. So if they are
hmm,
not having much exposure, then they may feel daunted if they are given some tasks that is different from their normal tasks. But
hmm.
if somebody is like even a little bit acquainted with the different fields as well, then they'll figure it out and make things work.
Yeah, yeah, yeah.
Yeah.
Yeah, perfect. So I hope everyone you got some point about this project. So I'm recommending, like, at least you are a machine learning developer, you are little bit, going to starting point to at least we are a little bit serious about machine learning. So I think this type of project is going to show you like different a different level of learning. Moreover, you will get to you don't know which industry will work on, and we will get to chance work on. But obviously there is different many use cases of this type of project. So if you work in this type of project, you also based on this we can work different type of video related work as well. Okay, so I hope you already got some point, and if there is some doubt, you can also connect with us. Like our developer will help you, one by one, connecting with one by one sessions. So maybe Google Meet, or directly you can connect with our mentor, our developers, and our team members, and you can learn how the things actually working. Okay, so maybe if we are watching this video and this video is helpful for you, you can do by your own. So that is already totally fine. But still, if you are upskilling yourself, you want to build or sharpen your skills, so this type of project is going to give more weightage to your resume. Okay, so I'm recommending, like, you go through this project, run by your own, or just little bit search about this. And also, if need any type of help, either maybe building the complete project, maybe deploying this project, or maybe also in some point of time, just want to get familiar with this type of project, so you can also directly connect with our with us, and our team member, our developer will help you, as even we can do like hand holding stuff as well, if this type of help. Okay, so that's all, everybody. So I hope you got something. If there is some doubts, you can also comment below, and we will try to answer your comment if there is something informative and useful for us. Okay, so that's all, everybody. So now, if Pratibha has some final notes, she can also say to this, or maybe we can uh, close this one.
I only want to say that keep practicing if you are into it, and try to work with a different variety of data.
Mm. Okay.
Yeah.
Okay, perfect. So that's all, everybody. Thank you so much for watching this video. Let's meet in another one. Till then, keep learning.